So for those of you watching this video, I sincerely hope that this video is like a pre-lab video for you, but I also understood when I was making these videos that these were meant to be alternative lab assignments in the event that students have to miss labs or we end up having to go purely online. So for those of you who are watching this video because you are having to do this as an online lab, I am sincerely sorry that you're having to do this. Because the synthesis of aspirin is actually one of those kind of like rites of passage for organic chemistry. I still actually have the aspirin that I synthesized when I was in high school. And this is really what kind of set me on that path for really enjoying chemistry. The synthesis of aspirin is one of those very interesting reactions, and it's a great demonstration of both how someone can use organic chemistry specifically to make great breakthroughs, while at the same time getting completely wrong. So, salicylic acid is this compound here. Now, salicylic acid is something that's easily extracted from willow bark, and this was actually what it was used for. It is an anti-inflammatory, non-steroidal, anti-inflammatory drug like aspirin. But two things about it is, one, it's not nearly as effective as aspirin, and two, it's actually very hard on your stomach lines. It ends up giving ulcers. So the chemist who discovered aspirin, did the first synthesis, was actually developing this because his father was having to take large amounts of salicylic acid and it was giving him very bad ulcers. So he said, well, let me do this reaction. So I'm going to run it with acetic anhydride. And I say this is kind of a bit of irony of history. He was trying to get rid of that functional group, but what he ended up doing was getting rid of that functional group. And what he ended up getting was acetylsalicylic acid. So this is what we have when we think of aspirin, acetylsalicylic acid. Now, acetylsalicylic aspirin is a much more effective anti-inflammatory drug than salicylic acid. It also has substantially less issues with inflaming the linings of your stomach, so you're less likely to get ulcers. Now, this has a phenol functional group. This does not. So if we want to verify the synthesis, we can easily just do ferric chloride test or an iron plus 3 test. And what will happen is that this iron plus 3 will coordinate with the salicylic acid, but it won't coordinate with our acetylsalicylic acid because it lacks that phenol, that OH in a benzene ring group. So this is what we're doing with the synthesis of aspirin lab. It's a very simple experiment, but basically we're taking salicylic acid, reacting with acetic anhydride, and we're getting the replacement of the phenol with an ester, and the other product here is our acetic acid. This is very soluble in water. This is sparingly soluble. So they're also very easy to separate. And yes, this was a beautiful example of chemistry in motion.